Alright class, in this lesson we're going to take a look at solving rational equations. Now this time we're not just simplifying expressions, but we're actually solving for x in these equations. Now the nicest and easiest way to do this is a process called fraction busting, where you actually don't have to play with fractions at all. But you can't do that until you decide what x can't be. Now we have an issue with x whenever x is on the bottom. There's potential that we can make x or plug something in for x that will cause the denominator to become 0. And so what we need to do before we actually solve for x is see what x can't be. So on the bottom here we have to set each denominator and say x, the denominator, cannot equal 0, and here the denominator to x can't equal 0. So then you need to solve those to see what actually causes x to be 0. Well, in this first one it's just 0. In the second one it's also just 0. If you divide by 2, you still get x can't be 0. So that means if we solve this whole problem and as an answer we say, oh, x is equal to 0, we actually have to go back and say, oh wait, that solution is invalid because at the beginning we said x can't be 0. Okay, so I'll erase that and I'll put it off to the side. So we're going to remind ourselves that x can't be 0. And then we go ahead and work on solving. Now we solve by multiplying by your common denominator. The common denominator here is 2x. Because I can make this 2 turn into a 2x, I can make this x turn into a 2x. But I don't actually want to because I don't want fractions. What I want to do is multiply the whole thing by 2x at the top. Because something very nice happens. So if I multiply each fraction by 2x, this far right fraction cross cancels. On this second fraction, just the 2 cancels. And on the first fraction, x and x cancel, and all I have, I'm not left with any fractions at all, which is the wonderful thing about what I just did. I'm left with 2 times 2, which is 4, minus 3 times x, which is 3x, equals 7. No fractions. So we just took a problem that looked complicated and made it a problem that has no fractions in it. I lost my equal sign. And we have a simple 2 steps to solve for x. To finish solving, all I have to do is subtract 4, and I get negative 3x is equal to 3. Divide by negative 3, and I get x equals negative 1. And because that's not equal to 0, it is a valid answer, and I've solved this problem. So again, this is a process I call fraction busting, which means I'm busting the fraction, I'm getting rid of the fractions, by multiplying by the common denominator of 2x. Okay, and that's your common denominator. Alright, so let's take a look at another type of problem. So this one, we've got binomial bases, denominators, and so what we want to do again is see what the common denominator would be. And if you notice that this x squared minus 9 is actually difference of squares, and if I factored it, it would factor to be x plus 3 times x minus 3. So the question then is, I want to know what my common denominator is that I can multiply all fractions. Well, I could easily make this second fraction into this fraction, or that denominator, by multiplying by an x minus 3. I could easily make x minus 3 into an x plus 3x minus 3 if I multiplied it by an x plus 3. So my common denominator is this last fraction's denominator. So that is the denominator that I want to multiply everything by so that I can fraction bust. So if I multiply each of the tops by x plus 3, x minus 3, I'll get rid of my fractions. So you can watch this work out here where x plus 3, now I cross cancel each fraction, so this turns out to x plus 3, cancels out with that x plus 3, x minus 3 crosses out with x minus 3, and over here I've got x plus 3, cancels out with this one up top, and I'm left with the 3 times the x minus 3, and on the first fraction I'm left with x minus 3, crossing out the x minus 3. And so now I'm just left with 2 and times the x plus 3. So I'll write that 2 times x plus 3 minus 3 times x minus 3 from the second fraction. and the minus sign, don't lose that, equals just the 12. The denominator on the last fraction all canceled out. So you can see I have no more fractions to play with. All I have to do is distribute the 2. So I get 2x plus 6. I distribute the negative 3 on the second one, so negative x plus 9. Be careful to actually distribute the negative times the negative to get plus 9 there, equals 12. Now all I have to do is combine my like terms, so I get 2x minus x, and that should give me x. I get 6 plus 9, 15, equals 12. All I have to do is subtract my 15, and I'm going to get x equals negative 3. So is it because it was 12 minus the 15. And that causes it to cancel on the left-hand side. So x equals negative 3. Now, that's great. I found my solution, but we didn't do something at the very beginning of the problem. Hopefully you noticed, and maybe it felt weird to you. We didn't take a look at what the domain is, or what x can't be. That should have been my first step. Okay? Now, a lot of times you're going to get moving just like I did, and you're not going to think through, wait, what couldn't have x been? Because we get an answer of x equals negative 3, but we actually need to look back, and I'm going to go ahead and erase everything here, at what x can't be. Well, I'm supposed to set each denominator equal to 0. And solve for x in each case. So I should have added 3, and I would have got x equals 3. I would have got x equals negative 3 on the second fraction. And if I solve this one, it would give me the same answer. It would, if I added the 9 and get x squared equals 9, and then square root both sides, I get x equals plus or minus 3. In other words, x can't be these things. Put can't signs. Okay? X cannot be plus or minus 3. Well, that's what our last solution was. We had that very solution of negative 3, so that means that our solution is invalid. This is the solution we got, was x equals negative 3. Well, we just said right here x can't equal negative 3. So that means we actually have no solution to this problem. If you're canceling out at the beginning and saying x can't be one number, and then at the end you're saying, well, that's the only answer that works, well, that means overall there is no solution. So for this particular problem, you would have to click in the lab that there is no solution. Okay, well, let's do another example. Now, first thing again we want to do is find our common denominators, and it just so happens that if I factor this last fraction, it turns out to be t plus 3 times t plus 5, and you can check that using magic x. And so what you can see is that this fraction, to have a common denominator, needs a t plus 3. This one needs a t plus 5. So the common denominator is this last denominator over here. So that means I want to multiply each fraction by t plus 3 times t plus 5. And then we cancel like we've done every time. So the t plus 3 here cancels, and I'm left with t plus 5 times 1, but just t plus 5. Plus, in the second fraction, we get t plus 5 to cancel, and I get 4 times t plus 3. Okay? And in the last fraction, the denominators cancel completely, and I'm left with equals 2. So now I just go ahead and simplify by distributing the 4, and I get 4t plus 12 equals 2, and then plus the t plus 5. So now I just combine like terms, and I get the t's to combine to get 5t. I combine my 5 and my 12 to get 17 equals 2. And then I just have to subtract my 17 to the other side. And so that's going to give me 5t equals, if I subtract, it'll be negative 15. And then I finally divide by 5. And I get t equals negative 3. Okay? So now again, I waited till the end to check. I probably should have done that at the beginning. but I need to check my solution again to see if it actually works. And if you see here, this is t plus 3. I should have set that equal to 0. T plus 3 equals 0. And that would have, or can't equal 0. And that would have given me t cannot equal negative 3. So again, in this problem, I have no solution because the only solution that I got as an answer causes the denominator to become 0. So it's actually invalid. No solution would be your final answer here. Okay. Now at the beginning I probably should have also checked that t plus 5 can't equal 0. In other words, that t couldn't have equaled negative 5 also, but it doesn't matter in the end here. One final example. You'll see that each one of these denominators needs to be factored. And so what I'm going to do is factor them for you, and then we'll look at what our common denominators are going to be. Okay, and as you can see here, if you use the magic X, they factor out like this. And what we want to identify is which ones they have in common. Well, this fraction off to the side has a k plus 1 and a k plus 3. So that means it's missing the k minus 2 that these other two have. Okay, so basically our common denominator needs to be a k plus 3 times a k plus 1 times a k minus 2. And then that would be what all three of them have in common. In other words, this one would only need that k minus 2, this one only needs a k plus 3, and this one only needs a k plus 1. They're all missing just one. But I still multiply each of them by what this common denominator would be. Basically, if I was to add all those fractions up, that's what I would want my denominator to be. So that's what I multiply each one of these fractions by, to not have any denominators and no more fractions. So I multiply that by each one, even the middle one, k plus 3 times k plus 1 times k minus 2. And on the first fraction also, k plus 3 times k plus 1 times k minus 2. Okay, and now we go ahead and cancel accordingly. So the k plus 3 in the first fraction will cancel, the k minus 2 will cancel, and the only thing I'm really left with is the 2 times k plus 1. In the second fraction, I'm left with k minus 2 canceling, the k plus 1 cancels, and then it just turns into plus 1 times k plus 3. Now I have my equal sign, and I have my k plus 3's cancel, my k plus 1's cancel, and then I'm left with 4 times k minus 2. So you can see how this really long bad fraction problem turns out to be a pretty simple algebra expression in the end. So all I have to do here is distribute my 2, and I get 2k plus 2 plus k plus 3 equals distribute my 4, and I get 4k minus 8. So now I just go ahead and combine my like terms. So my 2k and my k turns into 3k. 2 plus 3 is 5 equals 4k minus 8. And now I have to bring my 4k or my 3k over to the other side, whichever way. Bring my 3k over here, and that'll give me 1k on the right hand side. And if I bring my 8 over here to be with the 5, if I add the 8 and the 5, it should give me 13 as my solution. So now I just have to check to make sure that that actually is a valid solution. Well, if I set the denominators each equal to 0, I'd have the k plus 3. If I set that equal to 0, it would say that k couldn't equal negative 3. If I set the k plus 1 equals 0, I would find that k can't equal negative 1. And finally, if I set the k plus 2 equals 0, I would get that k couldn't equal positive 2. So that means my 13 stands as my actual final answer, and there is a solution to this particular problem. Okay?